Okay, good morning everyone. We're going to pick back up with Hess's Law. Today we're going to be looking at something called finding the heat of formation. Delta HF, and don't get that confused with the molar enthalpy of fusion from chapter 10. In other words, how much energy is required to form a compound. And this is going to look like a lot of what we're going to do from the homework. So let's do this one. It says calculate the enthalpy of formation of octane. It says using enthalpies of formation and enthalpies of combustion. Solve by combining the known thermochemical equations. So let's say we wanted to find the heat of formation of this compound octane. Well, you guys have been kind of practicing this before. What goes into the formation of octane? You need 8 carbons, right? And you need 18 hydrogens. But you can't write hydrogen that way because hydrogen is one of those pesky diatomic gases that always looks like H2. So we're going to need 9 of these. Okay. Now, we already know how to use this table, B14. And it shows us the enthalpy of formation of a bunch of different compounds, but today that's what we're trying to find. So here's a new table. It says that these are the enthalpies of combustion, and here's the one that we're looking at, octane. Okay? So, if it is 5,470.5 kilojoules per mole, all right, to burn this stuff, what does that mean? All right, well, here's what the combustion of octane looks like. Remember that anytime we have a combustion reaction, we're combining it with oxygen, and that the products of a combustion reaction are always CO2 and H2O. Okay, and that we know that the enthalpy of combustion, delta HC, is negative 5,470.5 kilojoules per mole. Got that right from this table. Okay? Well, what we're going to do is we're going to try to use this equation to determine this heat of formation. And that means that we're going to make this our target equation and this one of our step equations. So let's do this like we've been doing, where we're going to take this step equation and we're going to flip it around backwards. Let's make sure that it's balanced. So there are 8 carbons here. We'll put an 8 here. There are 18 hydrogens here. We'll put a 9 here. And that's going to make this tricky because 9 oxygens plus another 16, right? 8 times 2 is 16. That's 25. So we'll just say 25 halves of an O2 here, okay? All right, so there's our balanced chemical equation. Let's run it backwards because we want octane as a product, because here it is as a product. So let's run it backwards. That means that now we have 8 CO2 plus 9 H2O yields C8, H18, and 25 halves of an O2. Okay. Now, we're got the C8H18, but we also need to get the 8C and the 9H2. So here's how we're going to do that. What we're going to do is we're going to use the heat of formation of these two compounds. It says right here, solve by using enthalpies of formation. If we use the heat of formation of this and this, you'll see what happens. Let's take this CO2. Okay, and let's use it as a step equation, but because we want to eliminate it, it doesn't appear anywhere up here in our target equation. We don't want it to appear in any of our step equations unless it's on the opposite side. So let's take this 8CO2 and make it a product over here. Now, if we were going to make 8CO2, it would require 8 Cs and 16 oxygens, but you can't have that because oxygen is one of these guys. So we'll just make it 8O2. Now, according to this table, right up here, we know the heat of formation of carbon dioxide. We know it. It's right here, negative 393.5. Well, that's if you're making 1 mole of carbon dioxide, but we're not. We're making 8. So let's multiply this by 8. So make sure you have your calculator handy. And we'll say negative 393.5 times 8 is now negative 3,148 kilojoules. All right, let's do the same thing with our water. We want to eliminate it, and we also need 9 H2s as a reactant. So we'll use the heat of formation of H2O, and let's specify that this is a liquid because there's multiple versions of water. Let's make sure we know that that's a liquid. All right, if you were going to make 9 H2O, you'd need 9 H2s, and you'd need 9 O's. But you just can't have oxygen. You got to have it like this. So we'll just say 9 halves of an O2. Okay? Now, if we were looking at our table, it tells us that water has a heat of formation, if it's a liquid, of negative 285.8. Okay? But we didn't make 1. We made 9. So let's take that negative 285.8 and let's multiply that by 9. This is now negative 2,572.2 kilojoules. Now, why did we go through all of this? Here's why. We are trying to get these compounds involved in this reaction from these three step equations here. Okay? So what we did is we took our combustion reaction because we knew the heat of combustion, this guy right here. So we wrote out our combustion reaction, but we ran it backwards to make C8H18 a product. We have 8C as a reactant. We need 8C as a reactant in our step equations, but we also want to use the heat of formation so that this 8CO2 gets canceled out by something. So we got to put 8CO2 as a product in one of our step equations. 8CO2 is a product of the formation of CO2. So we just use the formation equation just for the bookkeeping, ladies and gentlemen, just for the bookkeeping. So when we do it like this, look what happens. Our 8C shows up in both target and step equations. Our 9H2 shows up in both our target and step equations. We know the C8H18 already shows up because that's why we did this. Let's see if everything else cancels out. This 8CO2 is canceled out by this one. This 9H2O is canceled out by this one. And 25 halves of an oxygen. Do they get canceled out? Well, if you rewrite 8O2 is 16 halves, then that's 25 halves, and those cancel out. That means that our step equations are equal to our target equation. So all we have to do is add these up, and this is going to be the heat of formation of C8H18, negative 5,470. But is this value negative anymore? It was negative when we were writing it as the combustion, but we ran this backwards. So let's make this a positive number. Okay, so now we have positive 5,470 minus 3,148 minus 2,572.2. Ladies and gentlemen, the heat of formation of octane, negative 250.2 kilojoules, and you have your answer. Okay, so it takes some practice. We've never seen this before, so don't panic. I will post the answer key, and I would like you to try the other two problems, okay?